Welcome to my public lecture series in engineering. Today, I will be speaking on a topic that lies at the intersection of technology, innovation, and education in Nigeria. The title of my public lecture today is Engineering Education in Nigeria and its Sustainability in the Era of Artificial Intelligence. Your anchor person still remains Professor Michael C. Ndinechi. Artificial intelligence is no longer the future, it is the present. It ranges from automated design systems to smart manufacturing. It is transforming how we learn, work, and innovate. The question, therefore, is how can engineering education remain sustainable and relevant in this changing world of artificial intelligence? Please join us as we navigate this title using these headings. We will start by defining the key concepts, look at the historical background of engineering education in Nigeria, the role engineering education plays in the national development. We will talk about relevant engineering education curriculum, the engineering education in Nigeria in the artificial intelligence era. We also talk about the changing landscape of engineering education, sustainability in engineering education, and challenges facing engineering education in this artificial intelligence era. We will be ending with the strategies for sustaining engineering education, and we then conclude. Please put your comments in the chat section so that I can see them and answer them if there are questions or elaborate more on them as we go on. Thank you. Let me quickly start by asking, who is an engineer? Well, my definition for an engineer may be quite distinct from what you think. To me, an engineer is that man or woman destined to make the world better for the whole humanity. However, the wisdom of an engineer is not because he fabricates natural resources into heavy equipment and machineries, but because each of his actions is motivated by thought. According to Bertrand Russell, in his book, History of Western Philosophy, he said, an engineer is a civilized man and is distinguished from a savage, mainly by prudence or forethought. He also continued that the engineer is willing to endure the present pains and pleasures for the sake of future pleasures, even if the future pleasures are rather distant. So to solve human problems, one ought to know the people. Therefore, engineers must strive to be politicians, sociologists, scientists, artists, and so on and so forth. It is therefore the task as engineers to do all things capable of elevating humanity by eliminating human sufferings and tribulations. Therefore, in my thought, man must be either born as an engineer or trained to be one by way of education. And that is why we are looking at today the engineering education in Nigeria and how to sustain it in this era of artificial intelligence. Let us quickly define some key concepts. In the title, we have key words: engineering education, sustainability, and artificial intelligence. So, engineering education refers to the systematic teaching and learning processes that prepare students to apply scientific and mathematical principles to design, build, and sustain technologies that serve humanity. Sustainability, on the other hand, goes beyond environmental responsibility. It also means educational sustainability, which ensures that engineering education remains viable, adaptable, and capable of meeting present and future societal needs without compromising the opportunities of future generations. In this era of AI, sustainability means preparing engineers who are not only technically skilled, but also ethically responsible, environmentally conscious, and socially aware. Now, for us to continue, for the sake of the younger ones, let us quickly take a second to look at the historical background of engineering education in Nigeria. And it goes thus. The national policy on education that was rolled out in 1981 stated that the national engineering education should, one, provide trained manpower in applied science, engineering, and technology, and two, provide people who can apply critical scientific and engineering knowledge to the improvement and solution of environmental problems for the use and convenience of man, amongst others. But the important thing here is that Nigerian government, as at 1981, recognized the fact that the development of Nigeria depends on how well engineering is taught to the next generation. Probably the generation now is the next generation they were looking at in 1981. So it becomes very important that we talk about how the present generation will be, taught engineering. Quickly, engineering education in Nigeria started in 1957 at the Zaria branch of the Nigerian College of Arts and Science as an extension of the University College, Ibadan. It adopted what is known as the mid-19th century Universities of London model, where students trained for the BSc Engineering degree of the University of London. In 1962, the Faculty of Engineering of Ahmad Bello University came into existence, but the special relationship examinations for the University of London degree continued till 1965. The University of Nigeria and Nsukka UNN Faculty of Engineering came into existence in 1961 as the first engineering faculty in Nigeria and was quite distinct from the University of London, the Zaria model. The UNN made extended university admission to holders of the school certificate or ordinary level general certificate of education, GCE. It allowed a 4-year program for holders of advanced level general certificate of education qualifications and a 5-year program for ordinary level entrants. The University of Nigeria and Nsukka faculty developed its own curriculum in agricultural, civil, electrical, and mechanical engineering with special objective to tailor the curriculum to the needs of the country. University of Lagos followed in 1964 and adopted the 3-year University of London structure, of course, with strong UNESCO support. Then in 1970, Obafemi Awolowo University started and added chemical engineering and food science and technology. And probably that is why, if you look around you, most of the senior chemical engineers in Nigeria are products of Obafemi Awolowo University. Then, 1971 saw the coming on board of the University of Benin Faculty of Engineering, which introduced a special concept known as the industrial attachment principle. And of course, this industrial attachment principle is still in existence till today. After that, other faculties of engineering sprang in rapid succession. But in 1980, the Nigerian government realized the yawning gap and shortfalls in the engineering curriculum and started the establishment of federal universities of technologies. The idea of universities of technologies was to have a remarkable deviation from the existing ones, otherwise known as the conventional universities. The sole aim was to bridge the gap between industries and academia. These universities were mandated to train the critical manpower in the areas of agricultural, electrical, electronics, metallurgy, materials, petroleum, chemicals, civil, mechanical, food, polymer, and textile engineering. These fields of engineering were identified to be the bedrock for the rapid growth of engineering, the rapid growth of Nigeria, especially in the areas of technology and economic self-reliance. They were charged with the mandate to harness and develop indigenous technologies of their catchment areas. Now, what are the roles of engineering education in national development? I will say that, without education, development will rarely occur. It is only an educated individual that can acquire skills necessary for sustainable economic development, more especially in the digital economy era we found ourselves in. According to World Commission on Education and Development in 1987, sustainable development, which is defined as the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And the UNESCO, in its curricula in 1988, produced the contributions of the conference organized by the then French President, François Mitterrand, tagged facing the challenges of 21st century, threats and promises. In that conference, some communiques were issued at the end, which include one, that education must become the absolute priority in all national budgets. Two, that science is a form of power and access to science must be equitably shared among individuals and peoples. And three, that science and technology must be made available to developing countries in particular to help them gain control over their own future and define the knowledge they deem necessary for their development. And that is why it is very important that we start talking about engineering education in this era when artificial intelligence is taking over everything so that we don't lag behind as a nation. So developing countries like Nigeria are not only called third world because it is behind in education anyway, but rather because it is far behind in science, technology, engineering, and mathematics, otherwise known as STEM education. In real sense, engineering and technology have transformed the way we live, and with each passing decade, the changes are more remarkable than the last. It can be argued to a reasonable extent that Michael Faraday and James Watt, from their scientific inventions, freed more men and women from slavery, otherwise poverty, than Abraham Lincoln. Maybe we leave this discussion to another day, but I believe in that. Science and engineering, of course, increases comfort, reduce unhappiness, and of course, poverty. Now, let us look at the relevant engineering education curriculum that we need to have to be relevant in this artificial intelligence era as a nation. The National Universities Commission, NUC, has recently harmonized engineering curriculum in what is called the CC-MAS, that is, Core Curriculum Minimum Academic Standard. In that CC-MAS, only 30% of the curriculum is left for universities to use to harness the potentials of their catchment areas. It is my belief, as will be discussed later, that this 30% negates the reason, the aim for the establishment of universities of technologies, which was mandated to develop technologies that will enable them to harness the potentials of their catchment areas. And I say that this seems to be at variance with the principle behind the establishment of universities of technologies charged with the mandate to harness and develop indigenous technologies of their catchment areas. However, for digital transformation to occur in any country, digital economy skills must be developed and sustained in that country as the key enabler. Instilling the necessary skills must form a key strategy of any nation's digital transformation strategy. Well, such skills must include, but will not be limited to, being able to search for materials online, using emails and other instant messaging tools, using private network platforms, and the other knowledges of digital financial services. No, the skills must go beyond these basic ones. With the explosion of artificial intelligence, a new niche of skills acquisition need to be introduced to the engineering curriculum other than the ones already contained in the CC mass to equip the students for the challenges ahead. Now, let's look at what engineering education in Nigeria as of today should be like. We are living in an extraordinary age, a time when artificial intelligence is reshaping every aspect of human endeavor, from healthcare and agriculture to energy, manufacturing, and education. Therefore, engineering, being the backbone of technological advancement, stands at the epicenter of this transformation. Yet, as we embrace these breakthroughs in artificial intelligence, an important question arises. And the question is this: how can engineering education remain sustainable, relevant, inclusive, and future focused in this rapidly evolving AI driven world? Let's do some put in some effort to answer this question. First, we look at the changing landscape of engineering education. So AI has become a game changer in engineering education. Today, machine learning algorithms can analyze data, simulate complex systems, and even predict design outcomes with remarkable precision. Tools like MATLAB AI Toolbox, Autodesk Generative Design, and ChatGPT-based tutors are helping students visualize and solve engineering problems faster than ever before. However, this transformation demands new learning skills and learning models. The first one is to move from rote learning to problem-based learning. Here, we are saying that engineering students must engage in solving real-world sustainability challenges in areas of renewable energy, smart cities, waste management, and climate adaptation using Internet of Things and edge technologies. If you want to know about IoT and edge technologies, I will refer you to my previous public lecture where we talked about this, and to some of my publications on IoT and edge technologies. Now, when we talk of rote learning, we are talking of a learning where students memorize what they are being taught without really knowing the actual real life practice of that thing they are learning or they have learned. So we say that the transformation demands a new or paradigm shift from this type of learning to problem-based learning. The next one is that we must move from individual learning to collaborative intelligence. What do we mean by this? We know that AI-driven platforms enable teamwork across continents, thereby fostering a culture of global engineering collaboration. And we also have to move from the traditional lab system to virtual and augmented environment. In this model, we are talking about having digital twins, simulations, and virtual labs, which are now key to sustainable and scalable learning experiences. When we talk of digital twins, we are talking of a virtual replica of physical objects, process, or system that is updated with real-time data from sensors. In other words, we can have two physical or more than two physical laboratories in developed worlds collaborating with the ones in developing world, having the same thing and the same data, because the data in the two labs are updated real time online through sensors or data collected from sensors. So this curriculum we are talking about must evolve to integrate AI literacy, data analytics, and sustainable principles into every engineering discipline. Now, what do we mean by sustainability in engineering education? Sustainability in engineering education has three main pillars: environmental sustainability, economic sustainability, and social sustainability. For environmental sustainability, we are saying that engineering faculties must promote technologies that minimize ecological footprints by engaging students in projects that relate to: one, renewable and clean energy systems; two, green materials and eco design; three, waste to energy and circular economy models; and four, sustainable infrastructure and transportation. For the economic sustainability, we are saying that for engineering programs to remain viable, they must produce graduates who are entrepreneurially innovative and employable. AI helps by offering predictive analytics for labor market trends, guiding curriculum updates to meet evolving industrial demands. Universities must therefore partner with industries to ensure continuous relevance, or they will become irrelevant. Three, social sustainability, and we are saying here that engineering education must serve humanity. AI should not widen inequality but promote inclusivity and equity. Online and AI-assisted learning tools can democratize engineering education by giving access to quality content, even in remote or underserved communities. Hence, sustainable education must be accessible, affordable, and all inclusive. Now, what are the challenges to achieving this sustainability in the AI era? So, despite its benefits, the AI revolution also brings challenges to sustainability. One, ethical dilemmas. Data privacy, algorithm bias, and misuse of automation can be a problem. Of course, job displacement fears. We already know that some engineering roles are changing or disappearing entirely, thereby creating anxiety among students, what their future will be on graduation, creating anxieties among even practicing engineers that their job roles are being taken over by artificial intelligence. The third challenge is the digital divide. We all know what it means: unequal access to AI resources, especially in developing countries. For curriculum rigidity, many engineering curriculum contents in the newly introduced CC Maths does not reflect current AI realities. You can go through the content of the curriculum again in engineering, in your own field of engineering, and see if it has enough AI realities in that content. And of course, the fifth one is faculty adaptation. Instructors and educators must continually rescale to integrate AI tools effectively, because most of the senior ones are just having some difficulties with this AI stuff. So they must continually rescale to be relevant. So addressing these challenges requires visionary policies, strong leadership, and a commitment to lifelong learning. So what are the strategies available for us to sustain engineering education in this era? So to ensure sustainability in the AI era, engineering education must embrace the following strategies. One, curriculum integration. We must embed AI, data science, and ethics across all engineering fields, all engineering courses. For example, civil engineering students should learn AI-based structural analysis, while electrical engineering system students must explore, you know, at least intelligent control systems. Two, our project-based learning should be in line with the sustainable development goals. So we say we must align engineering projects with the United Nations Sustainable Development Goal, especially Goal 7, which deals on clean energy, Goal 9, which deals on industrial innovation, and Goal 13, which deals on climate action. Then the third one is that there must be industry-academia partnership, whereby collaboration with industries to provide internships, mentorships, and joint research on artificial intelligence applications in sustainable technologies. Then four, we must talk about lifelong learning and upskilling. I've mentioned that earlier, that we must encourage continuous education through online courses, certifications, and AI-enabled applications to keep engineers relevant even after graduation. Then the fifth one is the ethical and human-centered engineering. Here, we must foster values of integrity, empathy, and responsibility in AI applications by ensuring that technology serves humanity and not the other way around. Now, as we are trying to round up, let us quickly, bring out the important notes in this our lecture. One is that NUC and Koren, we say Koren, Council for the Regulation of Engineering Practice in Nigeria, must quickly review the CC mass curriculum to integrate adequate AI literacy, computational thinking, data analytics, and digital creativity into every discipline. Two, AI is not replacing engineers. We must understand this. It is only empowering engineers. So if you don't upscale for AI to empower you, then you are creating room for AI to replace you as an engineer. The engineer of the future will not compete with AI, they will design it provided appropriate curriculum is used. 4, artificial intelligence is no longer a futuristic concept. It is a fundamental driver transforming engineering education and practice today. So we must not see it as something we are going to. It is already here with us. And that is why in one above, I talked about quickly reviewing the CC mass curriculum. 5, the engineer of the future is not defined by the tools they use, but by the wisdom with which they use the tools. In other words, in the presence of artificial intelligence, there must be human intelligence. And that is where the education comes in, because at the beginning, we have said that man can be born as an engineer or can be trained to be an engineer. In conclusion, therefore, I will say that a well-structured engineering education curriculum is key to the successful training of graduates with advanced active skills to be relevant in the artificial intelligence era. These skills can be achieved by rigorous pursuit of STEM education on one hand, and by acquiring intermediate and advanced skills in AI on the other hand. The NUC, through the CC mass, fell short of this by emphasizing in the old pattern of having so many common core engineering courses across the discipline, thereby limiting the possibility of introducing some modern core courses in digital, space and artificial intelligence. Current insistence that all engineering disciplines offer some courses which the CC mass made optional is also not the best, to say the least. For engineers to remain relevant in the AI era, they must learn to adapt, change, and innovate their services and take full advantages of the disruptive technologies and its associated skill set. Sustainability in engineering education in this AI era is not just about adopting new technologies, it is about transforming mindsets, rethinking pedagogy, and reaffirming values. AI gives us the power to model, predict, and optimize the world, but only sustainable engineering education will ensure that we do so wisely, responsibly, and for the common good. Let us therefore commit to nurturing engineers who are not just problem solvers, but planet protectors, innovators, and ethical leaders in this age of intelligent machines. And with this, we draw the curtain to our public lecture today. It is my hope that you enjoy the lectures. I want to see your comments, your reactions, so that we, discuss and iron things out. Please subscribe to my channel so that you will receive notifications of the subsequent, public lectures, which, in the next 2 weeks, we'll be talking about, the applications of AI in security. We can extend it to, national security, how AI can help us, and other aspects of AI. But before I go, I will tell you to remember that falling out of step in the rush to acquire AI skills can leave one at a permanent disadvantage. That is a quote from me, Professor Michael C. Ndinechi. Thank you for listening.